Here we go. Number one, what is spring constant? So spring constant, first of all, is the symbol K. And it stands for the strength of a spring. So it's how strong the spring is. Because C is taken. So we use K because it still sounds like constant, I guess.
What about S because it's spring?
S is taken.
And little s?
Yeah, little s is speed.
What about big S? Speed's
Little s and big S are too hard to distinguish from each other.
What about big C?
Big C is also constant. Or big C is coulombs. Okay, so K is the strength of the spring, spring constant. So what equation is used to find the spring constant? So it's F equals negative KD. So F is force, K is spring constant, and D is displacement. Now, it's specifically displacement from equilibrium. It's specifically displacement from equilibrium. So how far from equilibrium are you stretching? Okay. So the further you are from equilibrium, the larger that value for x is, or for d is going to be. The smaller you are from equilibrium, the less that's going to be. Okay? Okay. Number 3, for this lab, what does the force of the spring equal? So the force of the spring for this lab is always going to be equal to the force of gravity. So F is going to equal mg, which means when we set up this equation, it's going to be mg equals negative kx, or sorry, kd. Why is there a what? Gravitig. Okay. All right, last one, and then I'll show you how to do the measurements, and you guys can get started on those. So, rule number 1, never stretch the spring out with your hands. That's not what number 4 is. Number 4, what's up with the negative sign? So there's a negative sign in this equation. The negative sign means that F and D are always opposite signs. Which means if one is negative, the other is positive. But they're always opposites. Always, always, always. So you'll never have a positive F and a positive D. You'll have a negative F and a positive D, or a positive F and a negative D. But they'll never be the same. They'll always be opposite. So when you're doing that, just be careful when you're plugging in that you're making one of them negative. Okay. For the lab, you're going to be messing around with springs. I'm going to give you some springs to mess around with. I know. You're going to do the same sort of setup that we did for the pendulum lab. So you're going to get the hanger, you're going to clamp it down onto the table. Some tables already have this set up, so if you're already set up, you're in good shape. If you're not set up, you'll just need to grab the same materials that you did last time. Shouldn't be too difficult to do. Okay, what you're going to do is you're going to take the spring that you have and you're going to hang it with the loop over the black knob. It just slides right over and hangs down. Okay, couple of rules about the springs. Never stretch them out with your hands. Never put more than 200 grams on them. And when you're not taking measurements, don't leave the masses just hanging there. Okay? So the first thing you're going to do is you're going to write down which spring you have. So for me, I have spring G5. So I'm just going to write down G5. Don't you write down G5. You're not going to have spring G5 necessarily. Okay? Then, without anything attached to the spring, you're going to mark the spring's equilibrium position on the meter stick and write it down. You're going to place the 50-gram hanger on it and write the displacement, and then you record your values for 2 more masses. So what you're going to do is you're going to put the meter stick next to the spring, and you'll notice the springs have a little red arrow on them. You're going to put on your paper what the value is for where that arrow is. So I'm looking at my meter stick. I got my meter stick just sitting right next to me here. And I'm looking, and mine is at 78.5. So I would write down here with 0 weight on it, my position is 78.5. In meters, that'd be 0.785. Then I'm going to put the 50-gram hanger. So we're going to use these this time. We didn't use these on the last slab. We're going to use them on this slab. Okay? You're going to put that 50-gram weight on the hook. Okay? And all you have to do is write down where the spring is now. So I'm going to look at mine. I'm looking at where that little arrow is, and my arrow is at 77.5. Okay? So my mass is 50 grams. My mass in kilograms is 0.05. Okay? My position off the ground is 77.5. And so in meters, that's 0.785. Or sorry, 0.775. All right, and then the last step is to find the displacement. How far from the starting point am I? I was at 78.5. I'm now at 77.5. So my value, the difference, is 0.01. That's it. Do that for 2 more masses. Don't go more than 200 total. 200 total. Don't go more than that. So don't use the 500 at all. Don't use the 500 at all. Caroline, I need you paying attention. Okay? So you shouldn't go more than 500. Once you get to the back, you're going to use the equation from the front to calculate. I would get the measurements first. I would do the measurements first, do the calculations later. Okay? Get the measurements first, do the calculations later. Okay? And that's it. That's the whole lab. So you should be able to finish or at least get a good way through it today. And I'm going to really stay on you guys to get going with the measurements and to keep on it. Because you're going to fall behind really early. And I don't want you to get left in the dust because you're going to have a really hard time digging out. And this lab is going to be worth a lot of points. This lab is usually worth like 35 or 40, and most labs are worth 10 or 20. So you really want to stay on top of this lab. That's why we took so long on Lab 1, so that you could use Lab 1 to help you with Lab 2. But we're not going to go as slow on this one. So just kind of keeping that in mind as you're going. Okay? Anyone have any questions for me on this?
So the second last one, the third last one, those are going to be the same measurements?
Well, yes, they're just one's in centimeters, one's in meters.
Okay.
So this is 77.5, this is 0.775.
Okay, and then when you find the last column,
Yeah.
you have to subtract the first one, and then whichever one you're on?
Correct. So it's always going to be, for my example, it would be 0.785 minus whatever one I'm on. Yes.
Okay, thank you.
Yep. Okay. All right.